Well, the next is bromide ion. For that, we take the salt containing bromide plus concentrated sulfuric acid plus MnO2 and heat the mixture. Red-brown vapors of bromine are evolved. The first test is bring a filter paper moistened with starch and Ki solution. We call it a starch iodide paper. In contact with the red-brown vapors near the mouth of the test tube, blue spot with some orange stems are developed on the paper. The redox reactions are 4H plus MnO2 plus 2Br minus on heating. We get Br2 gas plus Mn2 plus aqueous plus 2H2O liquid. Br2 gas forms red-brown vapors of bromine. Next, Br2 plus 2I minus, we get I2 plus 2Br minus. The iodine thus produced reacts with starch to give iodine starch complex, that's a blue complex or blue color spots are formed. Besides this, at some places on the filter paper where there was no starch iodide solution, due to condensation of bromine vapors, orange colored stains may appear. On the other hand, if we bring a moist litmus paper in place of starch iodide paper, then it becomes colorless due to bleaching, that is oxidizing properties of Br2. Second test is take the salt containing bromide, to that add silver nitrate aqueous. We get AgBr, that forms a light yellow precipitate. This precipitate is also insoluble in dilute HNO3 but soluble in concentrated aqueous ammonia or potassium cyanide aqueous and Na2H2O3 aqueous solutions. Remember, silver chloride is soluble even in dilute aqueous ammonia, but AgBr is not. The third test is organic layer test. For performing this test, take aqueous solution of the salt or of its sodium carbonate extract. Add some chloroform or carbon tetrachloride to this solution. Since chloroform or carbon tetrachloride is heavier than water and immiscible, hence it will form a lower layer in the test tube. Now add some chlorine water and shake the solution. The organic layer becomes brown. The reactions are Cl2H2O, that is the notation for chlorine water, is an oxidizing agent. Hence, 2NaBr plus Cl2, we get 2NaCl plus Br2. This bromine, being less soluble in water but more soluble in chloroform or carbon tetrachloride, goes into the organic layer. Now, if we add chlorine water in excess and shake the solution again, then the organic layer becomes yellow due to formation of BrCl, that is bromine monochloride. Now we have confirmatory tests for iodide ion. For that we take salt containing I minus, add MnO2 and concentrated sulfuric acid to it and heat. Violet vapors of iodine are evolved. Now we can perform the first test. Now bring a filter paper moistened with starch solution only in contact with these vapors of iodine. Blue spots of iodine starch complex are formed on the filter paper. The reactions are 4H plus MnO2 plus 2I minus. On heating we get iodine gas plus Mn2 plus aqueous plus 2H2O liquid. Then iodine plus starch, we get blue complex, iodine starch complex. However, if we replace the starch paper by a moist litmus paper, then there is no action on it because I2 is much weaker oxidizing agent as compared to Cl2 and Br2. Hence, it cannot bleach the litmus paper. Well, the second test is, take the salt containing I minus and to that add silver nitrate aqueous. We get a dark yellow precipitate of silver iodide. Silver iodide AgI is very slightly soluble in concentrated aqueous ammonia, but is soluble in KCl and Na2H2O3 solutions like AgBr, like AgCl and AgBr. The third test is, take the salt containing iodide ion and to that add mercury chloride aqueous solution, so that we get mercuric iodide precipitate, that is a scarlet precipitate plus 2 chloride ion. This precipitate dissolves in excess of Ki. So HgI2 plus 2 Ki, we get a soluble complex which can be represented by the formula K2 HgI4.